assuring you this is going to be power-packed with knowledge. I'm going to request everyone to take up a comfortable position and make sure you pick up on a drink, a refreshment, while we have Jyoti leading us towards this session with her kind words.
Good evening, ladies and gentlemen. Again, another opportunity to welcome you all, but not in the morning, in this evening time. So good evening to all of you. I'm sure it has been a long day, right from the morning that you all have been busy in the booths visiting. Here we have our Board of Governors, the exhibitors, the visitors, and our friends from the IEC. So thank you all for taking time off to be a part of the CEO Summit. And today our topic on the CEO Summit is on sustainability to innovative technologies leading to net zero. Of course, this is the topic of discussion. Everybody's talking about net zero, everybody's talking about climate change. So today we have with us 6 eminent panelists who will be talking about net zero, and we have different subjects, different industries and what they think about. So we have lots of learning that is here. So I'd like to welcome Dr. B.R. Mehta, Mr. N.K. Srivastava, Mr. Anil Kumar. I believe Mr. Anil Kumar is on his way, that's why we just thought of waiting for some more time. Dr. K. Nandakumar, Mr. Vinayak Marathe, and Dr. V.P. Raman. So thank you all, thanks to our 6 speakers, and thank you all for being here. So it's time to, not to sit back, relax and enjoy as the pilots always say. So this is the time to just buckle up and listen to what the speakers have to say and see what we can learn and update ourselves from here. Thank you all and have a nice evening. Thank you.
Jyoti says, buckle up. I won't be surprised by the end of the entire session. Everyone is taking a flight to success. Let's look forward to that. It's my honor to introduce the panelists, and trust me, whatever I read about them is just the tip of the iceberg. So let's stay assured that there's so much more to their achievements than what we would say. I'd like to begin with the first panelist. Retired would not be the right word to use for him. I will just say he's probably a little slowed down. But after working with Reliance Industries Ltd, Mumbai as a senior vice president for the last more than 35 years, having more than 48 years of experience in refinery and petrochemicals industry, he's worked for engineering projects in the field of control systems and instrumentation. 2 years in agrochemicals and food corporation Kenya as chief instrumentation engineer, and Indian Petrochemicals Limited, Vadodara, for 11 years as instrument engineer. Was heading the design and engineering department in the field of control systems and instrumentation during the period he has worked with for many overseas licensors like UOP, Foster Wheels, RCI, and more. He is nominated as a member of End User Advisory Council worldwide for Fieldcom Group. Well, he has been 18 years with the Expert Club in Mumbai from its date, chairman of the Instrumentation Experts Club in Mumbai from date to its inception. He is also a life member of the club and elected as chairperson of India Customer Advisory Council of Honeywell Automation India Private Limited. Ladies and gentlemen, a huge round of applause for the most respectable Dr. B.R. Mehta. Thank you, Dr. Mehta, for joining us here today. Joining him on the panel, we have with NTPC Ltd for over 3.5 years now. He served as an Executive Director, IT and Chief General Manager. He's also played a very key role in the engineering of majority NTPC's coal-based thermal power plants, gas-based combined cycle power plants and hydro power plants. He spearheaded the development of new guidelines, policies and procedures in C&I engineering and IT, and is credited with the success of new bidding processes in NTPC. Under his leadership, Kavas Gas Power Project earned the reputation of being a zero accident plant for more than a decade. He has authored papers for national and international conferences, including the International Society of Automation. Knowledge is more valuable when it is shared, and therefore, sharing his knowledge with us, let's hear a round of applause for Mr. Manish Kumar Srivastava, Executive Director, Engineering, NTPC Ltd. Thank you for joining us, sir. Next on our panel is the founder and managing director of Chemtrols Group. Started in 1975, Chemtrols is India's leading solution provider for chemical and hydrocarbon processing industries and thermal and nuclear power plants. Specialization in petroleum refining from University of Kerala in the year 1970, he successfully had a career spanning with nearly 5 decades. Great Lifetime Achievement Award given to him, one of it being in Process Automation bestowed by Instrumentation Expert Club in 2017. He's a member of the American Institute of Chemical Engineers for more than 35 years now, a member of CII National Council and FICCI Capital Goods Committee, both since 2016. Ladies and gentlemen, let's make some noise and a big round of applause for Dr. K. Nandakumar, Chairman and Managing Director, Chemtrols Industries Private Limited. Joining us on the panel, India's business head for Phillip Townsend Associates, Incorporation, Townsend, USA, freelance consultant for O&M excellence, PSM, biofuel, R&D strategy and planning. Recent assignments with L&T, Aramco, Johnson, Marathe, HMEL and NCL. Former Senior Vice President in Reliance Industries Ltd. With 40 years of experience in operations, factory management, large green and brownfield projects, customization and digitization of world's best operation management system, world's largest algal biofuel plants and R&D strategy and planning. Recruited and mentored over 1,000 fresh and experienced engineering graduates from the top colleges in our country. He has received the Golden Peacock Award for 2 consecutive years for innovation management systems. There's so much we could say about the gentleman, but for now, let's hear it for Mr. Vinayak Marathe, Head of Indian Business Operation, Phillip Townsend Association Inclusive. We're talking about a postgraduate in instrumentation engineering and has over 42 years of experience with various engineering consultancy companies. He has the expertise in managing the total engineering and project cycle covering all engineering disciplines, using latest software tools, and has traveled worldwide on various project assignments. He has worked with reputed organizations like UHDE, Chemtech Engineering, Tecton Engineering, and more. He is associated with various professional bodies like ISA, IEC, IEG, etc. He was the past District Vice President for District 14 of ISA and is actively involved with ISA Maharashtra section for the last 20 years. He is associated with ISA USA in various standards and practices committee. He was the recipient of Excellence in Enduring Service Award from ISA USA in the year 2018. He has published several technical articles in reputed magazines like Control Engineering, Automation World, InTech, and more. Ladies and gentlemen, let's hear it for one of the finest engineering consultant, Mr. V.P. Raman. Joining us on the panel is another expert with 26 years of experience in diverse technical, commercial, operations and corporate roles in water and Renaissance infrastructure sector. He has extensive knowledge and understanding of the water and infrastructure investment in India and Asia. He has several senior management roles in project development, business operations, project financing, innovation and business development into infrastructure development sector. With an BE, MTech, a EVPM, that's an MBA, an LLB, and I don't know what else he is up to doing. But yes, currently he is working on his doctorate, all set to share the treasure of his knowledge. Let's hear it for Mr. Anil Kumar, the Managing Director of Water India Royal Haskoning DHD. Mr. Kumar will probably join us in a bit. Without taking away another moment of this precious time, I'll hand over to Dr. Vinayak.
Very good evening to all of you. I think you all had a wonderful time on the first day of the exhibition, and we really enjoyed looking at the new technologies coming up and the innovations made by many solution providers. In fact, we saw a lot of new technologies today displayed by many vendors, and I really like to thank them for coming out with such innovative solutions. Our today's topic is innovating to zero. Innovating to zero is a mega vision where focus and development will shift toward product and technologies with a vision and target of innovating to zero, bringing social innovation to the forefront. Automation will play a vital role in fulfilling this dream. How it all started? If you don't know, this was actually started in 2010 by Bill Gates. He first came up with the term innovating to zero to advocate a nuclear power plant. Technology that would be safe, reliable and have zero emissions. It is an idea that stayed in this world, set out to explore a zero concept world, where the vision of innovating to zero could be used to guide and achieve zero emission vehicles. The concept can be used for zero emission vehicles, zero waste, zero accidents, zero defects, zero security breaches, zero carbon emissions, carbon neutral buildings, zero obesity and even zero diseases. These were all the ideas of migrating towards the zero. So let's try to cover up some of the areas that we work and around us and how we can migrate to this net zero effect. Look at our work. Innovating to zero have many avatars like zero paper or a paperless office. What do we get by a paperless office? We get cost saving, we get increased technological capabilities, We get easier remote collaboration, better document and management and less time to search for the files, greater convenience and efficiency, environmental considerations, the ability to offer a better customer experience, more transparent and efficient finance processes, and more complete paper trails. So, if in our work we have brought in this zero paperless, paper, as you know, comes out of the wood, and to make paper you have been spending a lot of wood, which takes a lot of time to grow. So this was the first aspect which can be seen towards in our work, directing towards the paperless office and going towards the net zero. The next, let's talk about our cities. The perils of climate change are starker than even before. Even this month, New Zealand's zero carbon target was signed into law, setting country on a path forward to get net zero by 2050. It has been going slow, but if you see Holland, there are many of the roads specially designed for traveling by cycles. And this is one of the pictures of the center of Copenhagen, Denmark, where most of the people come on the bicycle. They park their bike right in the center park, which government has opened to reduce the pollution into the city. How we can get net zero with our buildings? Let's look at the carbon neutral buildings. When we operate using intelligent systems and renewable energy and are of the grid and harvest energy on site, will play an important role in cities' drive towards becoming the zero carbon. There was a treaty signed between many cities, London, Paris, New York, Johannesburg, Sydney and Tokyo, on a net zero carbon building declaration that any new buildings built in these cities will be net zero or carbon free. So what is the definition? We are going to the next word, it's a zero waste. And as given by the Zero Waste or International Organization, the definition of zero waste is already there on your board. And some of the countries and cities have started going towards zero waste, and some of the cities they are leading is San Francisco. It is by 2020, and they have not yet achieved full, but they have almost achieved 80% of that target. Now, how we can do this zero waste? There are three ways. You have three ways of waste. And if you look at this, you can do the waste for the landfill. And many items that goes into the landfill. If you see the green bin, these are the compact. So we create the composite, and this can be used as a fertilizer for the land. And the last one is try to recycle as much as it can. So with three concepts, you can reduce the waste to bare minimum as possible. If you look at the Hindus, and you see this, our earlier cremation ground was using more than 500 kg of wood, and it used to take 6 to 7 hours to burn a body. And today, we have migrated to an electronic furnace where the same thing is achieved in less than 45 minutes or 45-50 minutes, and there is no pollution. So this is one of the direction in which the Hindu community has also gone towards migrating into a zero waste. There are few benefits of net zero over health and well-being, over prosperity and environment. Talking about health and prosperity, it reduces the fuel poverty, more active lifestyle, and make diets easier and improves public health and reduce pressure on the NHS, which is National Health Services. Prosperity, it improves energy security, increases local economic productivity, creates new jobs and skills, and enhances opportunities for work and study. Environment, reverse the decline of biodiversity, reduce flood risk, improve water and air quality, and provides more accessible space. Now let's look at our transport. Actually, the automation industry has a big leap forward in terms of going to the zero. When you turn to the electrical vehicle, the three evils of industry, congestion, air pollution and road fatalities can be reduced. Two things are happening. There are EVs and then there are autonomous vehicles. When we go finally to autonomous vehicles, you will not only reduce the pollution, you will also reduce the accidents, and that will go towards zero. Let's look at our industries. We are all talking about digitalization and digital. So what do we want in digitalization? We want from the smallest personal items to the largest continents, everything everywhere will be digitally connected and responsive to our wants and likes. So let's look at our industry. Earlier, we were started with no maintenance or a reactive maintenance. Then most of the plants had a preventive maintenance which was scheduled after certain months of time. Then we went to predictive maintenance. Today many of the plants are doing proactive maintenance where they do a failure root cause analysis and find out the real root cause of the failure. But the next step will be self-maintenance by the device itself and maintenance-free machine. So that is a step which is taking us to the zero downtime and zero waste. So with this kind of maintenance technology, we will be able to increase the device reliability and reduce production downtime, increase the throughput, increase life expectancy of the asset, and improve safety and quality conditions. So how the future plant will look like? The future plant will look like horizontally and vertically integrated. Talking about right from the sea where you take into the crude, all the way up to the retail outlet where the petrol pumps are, everything is horizontally integrated. At the same time, from sensor to boardroom, it is integrated vertically. It will be wireless, self-diagnostic and self-healing. Many use of Vinayak technology structure. It can be remotely operated fully. No environmental pollution. It will have a positive carbon print, smart and green. But as the people say, the future plant will be definitely clean, silent, safe, energy, and it will be boring because there will be nothing to do for us. So how we can do this plan of conservation? It starts with the word of prevention, then minimization, then reuse, recycling, energy recovery and disposal. The disposal should be the last alternative into the cycle. We can try to do the prevention, minimization, reuse, recycling and energy recovery as much as possible. This will lead to minimum waste. And now let us look at last to the health. The scope of innovating to zero in the healthcare sector is enormous. For instance, net zero hospitals could guide the construction of hospitals in terms of ensuring greater energy efficiency while achieving the actual function of hospital. Zero medical waste and net zero surgery errors. There are many cases which fail because of the errors in the surgery. But with new technologies, we should be able to get zero surgery errors and likely to be no more emissions. So these are the areas where we are trying to get into zero. The next target will be going beyond zero. So tremendous investment is done by many countries, many governments in terms of money, in terms of human intelligence to put into service, innovating to zero. Despite the full knowledge that many of the goals will not be achieved. But we all of us should try and achieve as much as we can to go towards net zero, to reduce the pollution, to reduce the waste. And that should be the aim of the entire country, all of us sitting here. And that's with those words I would like to end my presentation. Thank you.
Call upon Mr. M.K. Srivastava. Please join us, sir.
Good evening, ladies and gentlemen. I was very keenly listening to Dr. Mehta, and he showed the importance of zero. And every country today in the world is racing towards how to approach zero. Now, when we hear the word zero, that makes me really proud. Why? Because who invented zero? Zero was invented by none other than an Indian, Mr. Aryabhatta. And really, we are able to see that what Indians could think of decades and centuries ago, that the world is seeing the force of zero. Now, all of us sitting here belong to the automation fraternity. Now, we being the automation experts, automation specialists, the prime duty, the prime job of us is to understand the process, optimize the process, and make the objectives meet to the fullest. Code is the process which we optimize, which will make it efficient, which will make it accurate, and the output is delivered. Up till now, the processes were well defined, very well defined. Knew what to do and how to do. Now, but with the climate change, the way it has emerged, the way we have realized that is going to change everything. It's a disruption that is going to happen, which has not happened ever before. I will draw your attention to the middle part. We see the world burning. Now, why so? Then let's come back to the left-hand portion. Here, the scale has been divided into several colors, green colors, which is okay for us. Then is the yellow, orange, red, yellow. the global warming, which is the major threat. As of now, the global warming has reached up to 1.2 degrees centigrade. And if whatever we do, whatever we have thought of, to the fullest and the sincere we do, we will achieve the global warming will go up to 2.7 degrees centigrade. That is where we are heading. If we do the NTPC targets defined for 2030, then we will be reaching 2.4. If we go to all the long-term pledges up to 2030, we will be reaching 2.1. And in the COP26, if everything is done, what has been said by all the leaders of the world, then also we will be achieving going up to 1.8. That means we will be in the orange zone. And today with 1.2, we are witnessing the extreme weather condition. This is just the tip of the iceberg. I am repeating, it is tip of the iceberg. Biodiversity lost and large-scale submersion. If we don't take the step what we are supposed to take, definitely, maybe a few years from now, we have to shift this Automation Expo somewhere in the northern part of the country. We are on the extreme right side. If we meet all the COP26 goals, then the entire GDP in the world will be reduced by 11%, and most affected is Asia, which will go minus 15%. And the last portion is very, very critical, because it is the energy. Now, for all new technologies, for all new innovations, energy is required. And the methods, what we know, how to convert energy, that is involving this greenhouse gases, these pollutants, and it is enhancing the global warming. So it is a very, very vicious circle. Now coming to the Indian context, we see the sector. As per since I am from the power sector, I will restrict the transition to this sector only. We have so many regulators, policy making, system operators, then NTPC, what NTPC is, and is sharing with you about. The energy consumption, we are 104th. Per capita CO2 emission, we are 116th. That means, as with respect to the greenhouse gas emissions, India is far way behind. Then why India is so much concerned? Let me put before you some of the figures. USA, one of the most developed countries of the world, they have already generated more than 500 billion tons of CO2. China 280 billion tons, Russia 180. India, it's of the order of 85 billion tons. That means we are nowhere compared with them. But exactly what has happened, if you divide the entire globe into a carbon space, they have eaten our own carbon space. And this is very, very critical for India, because as of today, we have not yet achieved the energy security for our country. We are looking at the energy options, the energy power generation options, which will make us energy secure. And in the midst of that, we have been asked, or rather we have been compelled by the world, that we need to go for transition. For a country which is ready to have energy security, it being forced to an energy transition. That is a very, very difficult situation for India. For India, we always believe that we will support the world come whatever may. So, 2015, India itself committed its INDC that if we reduce the emission intensity by 2030 when compared to 2005 level by 30 to 35%, the cumulative power that we require by the 2030 would be from the renewables. And the carbon sink, that will be additional carbon sink of consuming about 2.5 to 3 billion tons of CO2. In the recently concluded COP26, our Honorable Prime Minister gave the 5 Panchamrit. We will reach 500 gigawatt non-fossil by 2030. It's a really daunting task, but I am sure that we Indians will go much beyond that. By 2030, 50% of our energy need will be met from renewable energy. We will reduce the carbon emission by 1 billion tons. The carbon intensity will be reduced by 45%, and by 2070 we will be achieving the net zero. But I am sure we will be achieving before that. And by 2070 we will show to the world that we are carbon negative. I will invite your attention to the right hand corner. In this graph you can see clearly that coal, which is occupying as of today 32% of the total power generation, with the time 2030, even though the quantity will remain almost the same or will slightly increase, but overall the percentage will come down to 54. Renewables, which is a very, very lower capacity as of today, that will take an enormous 32% of the total. And in the bottom side you can see the whole coal is steadily coming down and the renewables is going up as we approach 2030. Challenges before the power sector. India is one of the few countries where we have abundance of coal. And there is no reason that, seeing our priority of energy security, why we should shed away from coal. But to continue with the coal generation, maybe on a reduced scale, till we have sufficient renewable capacity. There is a challenge how to reduce the greenhouse gases, CO2, SO2, NOx and the SPM. These are the technologies are being developed, they are in the maturity phase, as we have proved in the world, but for India it's a challenge because Indian coal has a high ash content. It is different from other parts of the world. So those technologies have to be modified and then it will be proven for our use. We are going very high with the renewables, but renewables, predominantly solar and wind, do not guarantee us round-the-clock power. To have the round-the-clock power, we need to have energy storage systems. That is the new process areas getting developed. Another important thing that is developing all across the world, many demonstration projects, pilot projects, research going on, is the hydrogen economy. Hydrogen is not a new thing. It's an age-old thing known to all of us generations before. But yes, now seeing the context of climate change, the importance of hydrogen providing energy to a country which needs energy security, that is growing momentum. And this is an area which I think that in the coming years, automation fraternity has to look upon and see how to make it excel in not only the hydrogen production, hydrogen storage, hydrogen transportation, hydrogen research, hydrogen utilization. So technical challenges. Renewables, as we all know, is very much dependent on the climate, on the weather conditions. And as we know, the weather changes very fast. To have a very good grid control, the base load stations needs to be very flexible. Here lies the challenge. Because our power stations, which have been come up about last 20 years, 25 years, they were not designed for flexible operation. Flexible operation is totally a different regime of operation. Now when we operate those equipments in today's flexible regime, those equipments are bound to fail. How to protect those equipments, extend their life and get the last bit from it, there lies the challenge. Efficiency and reliability is always the challenge of an automation engineer and will continue to remain so. Investment is also a touched upon better now. Financial. This is a very important thing. Which has undergone a change that very fast. For the first 3 bullets, we have made already very huge investment in the power sector, in the mining sector, huge investment. Now to maintain this investment, to run these plants and to do the spare part management for it, we need investment. Now, till we come to a solution where we have an alternate energy solution, meeting the climate condition requirements, we have an interest of time. Now, all the 3 bullets, if I go to a financer today, he says no. We are moved away from coal. So, to run this high intensive investments, where is the finance coming from? That is a big challenge for the sector. It's not limited to technical or finance challenges only. Social. As Dr. Nandakumar said in the morning, ESG, S is also very important. Social. And with the shift of energy transition, this S is going to be affected because the energy source, which is predominantly coal-based, if it comes to renewable-based, maybe the entire shift from one part of the India comes to the other part. Because the coal, which is predominantly in the eastern part, maybe for the renewables, for the solar and the wind, we may move it to the western or the southern part of India. So the entire business, revenue, the society, everything will undergo a change. And will the society accept it? That is a big question mark. It is not only the movement of the equipments, machine, plants. Who will run these plants? New technologies are required. But where is the knowledge? Where is the to acquire that knowledge? That itself is a challenge. And that knowledge has to be acquired by us. We are not in a position that will bring the experts from other developed countries and use them. No. Now we have to remain on our feet and we will develop our own expertise to run our programs. Although the title is Mitigation of Challenges, but this is my wish list. We can transfer affordable rates and demonstration pilot projects, soft loans. These are all wish lists. Whether it will be done or not, that will time will tell. Here I have selected two important things: technology transfer and financing. Now, when we need a project to be financed, one of the important things is that when does the output comes back? And in this energy transition, that we do not have. That liberty of time, unfortunately, we do not have. So we cannot start from the scratch. We have to see all around the globe, various research institutes, various serious players, that what they are doing. And then very carefully we have to select what is applicable for us. And then selecting that technology, we adopt it, customize it so that we can start at a very, very upper level so that we can deliver the output very fast. And the bottom portion, these are the technologies which will be the new processes where our automation fraternity has to contribute. Sustainable. Decarbonization and other emission control techniques, that is for the current energy power producing sources, which we have to take out the salts, CO2, SPM. Then these are the new technologies that is coming, that is the hydrogen economy, nuclear. Dr. Mehta also said that nuclear is the option that we have to go for. Energy storage, waste to energy, biomass, renewables. These are all the processes that will come. But what do the automation fraternity have with us? That is the right part of the presentation. That is the technologies, digital technologies. We have to master them, apply them on the processes, and then we have to deliver that how soon we are able to move and come to a reasonable level of alternate energy source for our country. If you say how the vast the changes, in 2021, my company, the plan was on the left hand side. It was basically a power generating company. we wanted to go to get coal mining, renewables, consultancy. Only 10 years. See the change. Now we are going into green hydrogen, EV transport, CCU and water. So this is what we know. Maybe this will undergo similar change after some years, which we have not thought of. This is briefly the role of NTPC. Here I have led to the third bullet that we wish to be a 130 gigawatt company by 2032. Now my company started in 1975, today is 2022, almost 46 plus. And today we are 68 gigawatt company. That means in a span of 46 years, maybe say touching 47 years, we have generated 68. And what is our target? Next 10 years, we want to do what we have done in the 47 years. That is the speed at which we have to work. That is the speed which our automation fraternity has to deliver. So this is the daunting task in front of us. NTPC was the first company which declares energy compact goals at the UN high-level dialogue on energy. What we declared, we will be 50 plus gigawatt company by 2030, and now we have revised it to 60 gigawatt by 2032. Energy intensity with respect to the 12 levels to reduce by 2030. And we join 2 international solar industrial alliances for clean energy all around the globe. We are on this path, and I'll just share with you. This is the global map with respect to our commitment of having 2 international alliances. We have partnered with ISA and we are promoting the handholding clean energy for South American and African countries. Hydrogen, this I already just touched upon this. This is the process and this is what we intend to do. I'll just share with you what NTPC has done. In May, we are giving the full hydrogen economy, that means from hydrogen generation, transportation, filling. We are running a hydrogen buses at Lake for protecting the environment, and then entire circular economy. Then we are going for carbon capture and green methanol production, green hydrogen based microgrid, then the green ammonia, hydrogen blending with natural gas, and hydrogen ecosystem. Now you see, it is not showcasing NTPC. What I want to show it to here, NTPC for so many decades was showcasing that yes, we are generating power. But now we are into this and will continue to increase year by year. So the automation fraternity also has to shift to these areas of processes. On the renewable front, at the moment we are 18 gigawatt with the distribution of 2 gigawatt commission, 4.3 execution, 5 under pending, 6.7 in outsource, and we are currently building 4.75 gigawatt, biggest national solar park in India on the western coast. These are a few other RE initiatives. We are into hydropower, waste to energy. We have already built one waste to energy plant at Varanasi. 48,000 of biomass pellets we have already consumed, which is a green fuel. And we intend to procure 20 million metric tons of biomass to be for 17 projects. Then we are also going for battery energy storage system on grid scale basis, megawatt basis, in mobility. This is in continuation to what I said earlier, that with these processes, which are new processes, and with the technologies which are upcoming technologies, we have to merge. This is the marriage we have to do. This I briefly have touched upon that automation for sustainable net zero. How automation can contribute? Automation can contribute by building on human machine internet technologies, which will comprise of robotics, 3D printing, cyber security embedded, asset management, AI/ML related technologies, which will include quantum computing, cloud native technologies, big data. Then operator 4.0. Now this operator 4.0 is a different operator what the operator is as of today. It will be enhanced what we discussed in the morning. But the machine and the men will combine. And when they combine, the combined force, the combined intellect, the combined wisdom, combined decision-making power, enormous. That will be operator 4.0. Hyper automation. This is an area which is a very, gather momentum. Digital twin. Already we have done digital twins has been talked for the last decade. But the form and shape of it will take will be totally different. In digital twin, the upcoming technology will be that what we design was to happen like that. But we'll give the intelligence that however that with the time and with the processes, whatever change needs to be done, it will be done. What Dr. Mehta said, self-managed machines, something like that. Advanced sensors and controls. These are technologies that will be the main domain for the automation engineers. So with that, I thank you very much for the patient hearing, and thank you very much.
Thank you so much, Mr. Srivastava. I would now like to call upon Mr. Anil Kumar to join us on this stage.
By the time we start the presentation, I'll just start talking. My name is Anil Kumar. I represent a consulting firm called Haskoning DHB. We are a Dutch-based consulting firm, and we are present in India from the last 30 years or so. So we do consulting into engineering, which involves water side, aviation side, ports and jetties, and industrial kind of projects. So today I will be talking about machine learning and AI-based tools which we have developed for water industry, and how that tool has helped, creating more efficiencies, optimization of the process, using the big data which involve into managing such large assets which carry huge investments and a lot of manpower, because water and wastewater treatment plants are very expensive for any utilities. It involves a lot of very skilled manpower, and today skilled manpower is very difficult to get actually into managing these assets. And when we do some knowledge transfer to these people, what happens after 2-3 years, the department transfer these people and the knowledge doesn't go to the people, and that's where our system fails. The large water treatment plant, wastewater treatment plant fails, and with the concept of bringing these automation valves, pumping systems and large SCADA and PLC systems, so many automation is happening in our country, for which we should feel great actually, compared to if we say like upcoming economy like Indonesia or any other country, Vietnam. We have actually better I would say specifications into our automation of these systems. But the point here is what to do with this big data which is there, how to use this historical data when we have 4 seasons in our country. We have drought season, we have rainy season, we have now winter season. So how to manage these water assets in a city? Sometimes we feel like water quality, especially in northern part of India, Delhi, is becoming deteriorated in summer because of nitrogen issues. Sometimes we feel like in rainy seasons, these plants are overflowing and it's very difficult to manage the bacteria in these plants and we are unable to operate it. So how to manage these fluctuations in these plants? I'll be just talking a bit about it. So thank you for inviting me, and sorry it's a bit late, so I will not take too much time. I'll just run through it in 10 minutes. I hope you will like it and find it a bit exciting. So we have been using many terms like digital twins, 3D modelings and all. So we actually transformed our company 20 years ago into this area. And you name any point of automation, whether it is aviation. So today I was just observing it's raining since morning, and nobody has thought about what is going to happen on the aviation transport when more than 500 flights are landing in Mumbai. So I'll just give you an example. They measure rainfall by putting a coin on the runway, on the top of runway, how many mm of rain is there on the runway and how it impacts the aircraft landing. So we have developed to that level of machine learning and AI base, and my presentation with few words like all these technology automations are actually small parts of solution. We can do wonders actually as a country, but I would say the acceptability of social and the stakeholders. Stakeholders are our politicians, bureaucrats or policy makers. That is the most difficult task which I got to. So with that I would say thank you. Thank you.
Thank you, Mr. Anil Kumar. As you rightly said, that was pretty interesting. Now I would like to call upon our next speaker, Dr. K. Nandakumar. Thank you, sir.
Good evening. I will try to complete my talk in 10 minutes time. I know it's late. I must say both Dr. Mehta as well as Srivastava has spoken about the potential or the requirements of the net zero or the challenges which we have. This morning I spoke about we consuming this year's targets already, which is known as Earth overshooting the day. Country-wise, if you look at it, it has got various dates. But one of the studies, there is an association in the United States which it does, even in Germany it does, about this calculation overshooting day, which is known as green gas or global warming potentials. As per the global warming potential, it is considered CO2 is the base for global warming calculation, global warming potential. It is considered over a period of time base of year. If CO2 has got 1, we always pick up CO2 because that is more critical for us. The reason for that is something, when you look at the others, the methane is 12 times more gas absorbing or heat absorbing potential. Whereas if you go to nitrous oxide, it has got a gas heat absorbing potential, something around 1200. And if you go to perfluoro oxy or hydrofluoro, it goes to something around 12,000 etc. So you can imagine these gases which creates the problem in the environment. And the problem is the heat. Because as the environment gets heated up, it doesn't move out of the ozone layer. So CO2 as the problem is, though it is the least, but it has got a capacity to remain in the environment more than 10,000 years. That is the biggest challenge for CO2. Whereas for methane, it's only a year, or other things much less year. But any other gas, CO2 has the capacity to remain. That is why we are all talking of how we can control the carbon emission. The reason for that is because escape of carbon dioxide from atmosphere is a much difficult task. So what we have to look at how to control this, our net zero is what is the low-hanging fruit? How do we capture that low-hanging fruit? And that is nothing but CO2 is the one which is looking at. What are the various means of how we can control? As both the speakers have spoken already, huge amount of money is required if we attach or if we attack all the requirements of net zero. It's for a country like India, it is a big challenge to get that money from overseas. So when we look at that, government has done quite a lot of work over the last 10 years in looking at the low-hanging fruit to get into net zero. So I would like to touch upon, while the big challenges are there, what the government has done over the last so many years. Before that, I will touch upon one of the petrochemical areas. That is one of the green gas areas which is creating, also carbon potential is coming up. Most of the consulting companies world over are really putting a lot of research, a lot of design engineering in creating the situation where an ethylene cracker or ethane cracker can be much more greener by way of whether the steam reforming process can be either altered or changed into an electrical furnace whereby the gas emission is less, or by having much better efficiency of the furnace. That also is working. So a lot of research has gone into, and most of the, I would say, engineering companies worldwide has done a lot of work on developing into basic fundamentals of the petrochemical for an ethylene cracker to get into a green. But it's a huge amount. And it's not only on the process, but when you go into equipment side, it's much higher. Given that ground, what is it that we have done in India? We know that we have 1.4 billion people, such a large industrial area, agricultural waste, and we have a lot of waste coming in. From the waste, how we can reduce the carbon, that is the biggest thing they have looked at. So in my opinion, the government has looked at the low hanging fruits, looked at potentials to create that, and one of the areas of focus is the biofuels. In fact, I must say that on 10th of August, the first 2G alcohol plant was commissioned in Panipat Refinery by our Honorable Prime Minister. When I say that is the first 2G advanced alcohol plant, not from a sugar plant, not from conventional, but from cellulosic fiber. Could be green or could be for any other. There are a couple of other plants being built up. One is in Nomalika Refinery, utilizing the locally available bamboo and done by a Finnish company by the name Chemtrols. It is under construction, it is working, or rather it's nearing. There are a couple of other projects which Hindustan Petroleum is doing. One is in Bathinda and the other is in Orissa. Again used on 2G. Technology is developed in India. ICT, Institute of Chemical Technology. Praj Engineering in Pune. Both of them have developed these technologies, and I must say the plant commission is producing, or rather will attain the rated capacity in short time in Panipat. So the government's a lot of focus on the low-hanging fruit to create a net zero is a lot of activities. There are some other areas like biodiesel. There is a biodiesel association, and biodiesel association also is creating a lot of, I would say biodiesel is still in lower because there are quite a lot of other economical hurdles is getting into that. That is creating some area, but government considering that last month has changed certain amount of policies by which attraction will be there, economic feasibility will be there for creating a biodiesel plant. There is also a research going on in aviation turbine fuel to get into biofuel. A sustainable aviation fuel, a lot of work. Then that green tea which is available, which can be produced for the aviation fuel, is not available in India, it's to be imported. But yet a lot of work is going on in developing that sustainable aviation fuel for this. And which is very essentially required because aviation creates largest contribution in terms of CO2 in the atmosphere. Large number of flights across any time in the country. So there are quite a lot of work is taking place. There is another initiative which is to any entrepreneur is very, very attractive is, Indian Oil, it's not an Indian Oil, it's a Ministry of Natural Gas and Petroleum. In the year 2018, brought out a scheme known as SATAT, Sustainable Alternative for Affordable Transportation. And it's nothing but compressed biogas from waste. There are letter of intents invited by the Ministry of Petroleum for 5,000 compressed biogas plants in the country to set up, to give a sustainable, affordable transportation for alternative instead of having the fossil fuel driven either diesel or a petrol. Which is, I personally understand, or I believe it's only 500 plants still out of 5,000 is commissioned. So that's an area where we need to promote, and it's a well-proven technology. Why well-proven technology? Because the biogas coming from all these waste, whether it is sugar plant waste or whether it is any other food waste coming in, has got CO2, around 30% CO2. So in order to remove that CO2 for 30% from biogas, recently, I won't say recently, a couple of years ago, new membranes is developed overseas. So that new membranes is brought, and it is much easy to produce a nearly equivalent pipeline quality gas from biogas, and you can inject that into our own city gas grids. Not necessary. So payment is also assured by the Ministry of Petroleum, where they will take care of the marketing. These compressed biogases will create a sustainable alternative, plus the young entrepreneur. So approximately, I would say, 15 metric tons plant is around 35 crores. And there is also recently, because over the last 4 years, out of 5,000 projects, only 500 LOIs, nearly 63 plants are only commissioned. government has recognized the importance of funding. So State Bank of India has come out with a special funding for these projects to get much lower cost. So it's a very viable alternative to produce, look at the low cost alternate for sustainable energy related to net zero. I must say that people should look at how we can get it. When we look at into biofuels, there are a couple of other areas which is coming not only from biofuels, there's advanced 2G ethanol, but there are a couple of other activities also converting. That is one of the things is CO2. What is the best alternative for CO2? Is it CO2 storage is possible? In my opinion, it's still a big challenge. Though there are technologies developed for CO2 storage, CO2 capture and immediate utilization is much better than CO2 storage because we do not have our soil research or soil capability developed to have CO2 storage. So CO2 from storage, immediate utilization, one is the production of, I would say, ethyl alcohol. If you look at CO2 and hydrogen, you have nearly 6 hydrogen molecules for 2 Cs you can get. Ethyl alcohol you can produce with CO2 and hydrogen, and you can again get. When you look at the hydrogen economy, there is a big challenge because today the cost factor of hydrogen is $5 per kg. With $5 per kg, hydrogen economy is not viable. In order to produce that into an economic viable, somewhere around $2 or maybe less than $2, but it's a big challenge. Producing a green hydrogen using electrolysis, because the metallurgy is still a long way. You have a metallurgy available for producing the caustic chlorine, but if that metallurgy used, you can't get hydrogen at lower cost. So you need a lot of research work going on getting into much better electrodes, much better, utilizing much better metallurgies. Now, that hydrogen with comparatively lower costs, we can utilize it without waste, without having a safety factor. Most important in the hydrogen is the safety factor because for transporting hydrogen from one area to another area, you need 700 bars. It's not an easy 700 bars of hydrogen transport across. So you need to convert that hydrogen into either ammonia, I would say liquid ammonia, or alcohol, ethanol. A lot of work is done on this because it's not that complicated technology. And it is much easier to crack an ammonia and get hydrogen at the point of utilization than transporting hydrogen from because of the safety factor. So hydrogen economy, though there is a lot of hype about it, in my opinion, it is going to take some time. Maybe 5 years, 7 years, until the metallurgy is developed, more safety factors are improved, or we produce hydrogen and convert it into, at the state of producing it in ammonia and crack it at the point of utilization to produce hydrogen, or from ethyl alcohol. So carbon dioxide has great potential in converting to viable alternate at lower costs by way of either ammonia, alcohol or other points area, utilizing hydrogen, green oil. Green hydrogen is going to be by 2050. If we look today, our consumption pattern is 28% of the oil is for transportation. So that is an area government has focused. 28% of the fossil fuel oil consumption is on the transportation. So can we not address that by utilizing, by looking at low-hanging fruit of carbon, converting into various alternatives? In my opinion, it's doing a lot of good work, especially on the biofuel side as well as on the hydrogen side. There is a couple of other areas where a lot of initiative is being taken place, but it is still a big challenge in terms of getting the availability of the raw material and on top of it, funding. So government's potential has been on to look at which is the low-hanging fruit, which can be easily at lower cost adapted and can be put into the market. And I must say that industry associations as well as IED and even these type of exhibitions should promote for low-hanging fruit conversion of CO2 into affordable fuel for transportation or affordable other fuels for other areas. Another area for hydrogen, especially in certain instrumentation areas, is converting into hydrogen fuel cells, utilization of hydrogen fuel cells. It's nothing but an equivalent to a battery. So there is a chemical energy converting chemical reaction. But quite a lot of work is being done in India in developing hydrogen fuel cells. Also you're looking at the safety factor. Because if you have a hydrogen, you have a storage potential hazard for 700 bars, or looking at by changing a small cartridge, you can utilize the instead of hydrogen either a methanol or aluminum oxide to produce a fuel cell. So a lot of work, various researches is taking place and looking at it. Now what is the role of instrumentation in this? And what changes instrumentation can happen? When I said large engineering companies are working on producing green ethylene cracker, everything else. There are also a lot of work demands on the instrumentation automation side. And the most, I would say, easiest way to achieve carbon neutral or low carbon is nothing but efficiency, either in the energy efficiency or process efficiency. If you are able to get into an efficiency level, you look at a refinery, which is the best refinery, which produces as that of the same product as a worst refinery. The energy consumption per volume of the product is 60% less. This is a study made overseas. A best refinery which produces the same product as that of the worst refinery, the energy consumed is 55% less compared to the worst refinery. So by having an efficiency level put in, you can have much of energy efficiency and also the less carbon. And that is the role of instrumentation. How do we get that energy efficiency? Looking at the sensors. Have the sensors properly calibrated, giving the results, and it's not sufficient alone having the data. Our problem is that we get the data, we forget. Today's technology, previous speaker spoke about the artificial intelligence, digital tools. Utilize that, analyze the data, and get into the where is the gap coming in? What are the problems in coming? So complete that circle, utilizing the data to get into much better efficiency. You can have at least 15% of the carbon content reduced. There is another couple of areas which will certainly affect instrumentation industry over the period. I won't say affect, potential. One is the emission, continuous emission monitoring. Today, continuous emission monitoring is analyzer-based system. It has got its own challenge. It gives a much better reading, much good. But is it going to stand when you talk of low carbon footprint? All plants will have low carbon footprint. So in my opinion, world over, continuous emission monitoring will be taken over by predictive emission monitoring. It is software driven, much better, depending upon the percentage utilization of this. It may not affect India immediately, but the potential that continuous emission monitoring utilizing the analytical systems will find its challenge from predictive emission monitoring. Because a continuous emission monitoring based on analytics, beyond the role of carbon, difficult to manage, difficult to maintain, costlier to maintain. So the users will look at how it's much better to have a predictive emission monitoring. Most of the licensors have done a lot of work on this and looking at various potential. So we instrumentation fraternity should look at what is the alternative we have, or how do we enhance our capability to have predictive emission monitoring system. Another technology in instrumentation area which I believe will remain and constant is mass flow meter, because mass flow meter is the one which gives you the maximum accuracy, because it measures not only the flow but also the density and gives you the correct reading efficiencies. So look at, the country should look at developing or rather collaborating with to produce mass flow meters in the country, because that's across. Third one again, I come back to the ambient air quality monitoring. There was a program in India known as NCAP, National Clean Air Program. Under that, Ministry of Environment and Climate Change had planned to put up 4,000 continuous ambient air quality monitoring in the country. This was around 3 years back. As on date, after 3-4 years, it's still around hovering around 300 numbers. There are various reasons, challenges in putting up money matter plus skills. But beyond that, again, it has got some challenges of whether carbon footprint can be achieved. Because again, analytical based, calibration gases, skills areas is looking at. And over the last 1 year, government has commissioned IIT Kanpur to develop sensor-based system. It's not only IIT Kanpur, all other IITs are collaborating with IIT Kanpur to develop sensor-based air quality monitoring system. And in some places it is done. There are some places inaccuracies is there. But government feels an inaccuracy of 10% can be accommodated compared to having very close tolerances for a country like India, because your cost factor is plus maintainability. An analytical reference station maintainability is much more costly, and even when we get the validity of the data is doubtful. So government is looking, commissioned on this, it's working very closely to develop sensor-based air quality monitoring system. And I am sure government also has taken a decision, instead of 4,000 reference stations, why not? Why not at least utilize sensor-based system in smart city programs? Major cities has got a smart city program, why not utilize it? So we should ourselves look at either the collaborating with the IITs or develop sensor-based system. There will be critical areas, but that will certainly. Another area again, looking at the air quality monitoring, we are looking at monitoring the quality of air. What is the energy we are using? Grid energy, which is produced by a thermal power plant or any other power plant producing again greenhouse gases. Can we not utilize the hydrogen fuel cell for these air quality monitoring stations? Self-contained, no problem. Very well work. There are 6 lakh mobile towers in the country. All of them have diesel generators. And most of them have either the diesel is stolen or no pollution control, no monitoring. So one of the critical areas looking at developing or replacing these, already there is a rule, there is a law that any diesel emission has to be properly monitored, whether it really working or not, but it is that. So looking at 6 lakh mobile towers, having 6 lakh diesel generators to replace with a self-contained, might be hydrogen fuel cell or any other fuel cell, where absolutely zero pollution. So a lot of areas, in spite of the fact that government has revenue limitations, a lot of work is done. And I must compliment our Navaratna companies working on this. There is absolutely no doubt. Indian Oils, BPCLs, HPCLs, GAIL, Petrochemical, all of them got Indian Institute of Science collaborating, IITs collaborating. Quite a lot of work in these areas is being done. And the coming days, along with that, there is a focus on the high end of the technology areas. No doubt on that. Hydrogen, of course. Large companies like Reliance, Adani, which are spending billions of dollars in developing technologies to get into affordable hydrogen at the rate of $2 per kg or $1 per kg. I must say that's a big challenge, but once we are through, but it's a process, it may take 5 to 7 years. So you can't afford, because We are already borrowing from India per se, still lower than, as Mr. Srivastava said. One study said Germany needs 3 years to meet the target of the global disease. India still needs only one earth, because India is still 0.85 of the normal target for that. There are challenges in it, but we can't remain isolated in India in the global economy, in the global footprint. So naturally we need to look at carbon capture, utilization, and at a later date storage. Storage, of course, is a challenge, as I said earlier. But it's possible to convert carbon capture into viable product like alcohol and utilize, or use again green hydrogen and convert to ethyl, and again crack that alcohol to produce green hydrogen. So quite a lot of work is there. I am confident that the Indian economy will overcome the problems we have. And thank each one of you for contributing, and to our instrumentation fraternity. Look at the challenges coming from new areas, new technologies, new requirements, and let us handhold our community to get out the problems we have. Because today's demand is not by choice, it is by compulsion. There is absolutely no way to get in the old one. So we need to. Thank you, sir. Thank you.
Thank you so much, sir. Our next speaker for the evening, Mr. Vinayak Marathe.
We have sensors around the airport. They measure the rainfall on the runway, and they can tell that how many flights can land in the next half an hour, and what would be the impact on passenger transport and baggage handling. You know, that involves huge cost actually. We don't feel it actually. So we have done these kind of work, and we are implementing these projects in Kochi or Mumbai, just to give an example. So, as I said, we are 140-year organization, independently staff-owned company. We don't have any shareholding. Our staff own this company. We are around 6,000 professionals, and we have undertaken more than 1,000 water projects all over India, 700 airport projects. You name any port in India, we are present. All over the world, we have done around 900 ports designing. So, in total, we have around 250 very skilled PhD scholars who are involving into developing these machine learning and AI-based tools for such sectors. And what we do is we understand the requirement of the stakeholder, how it adds value to the society, how is it future-proof, or it is a resource, can we recover some energy out of it. So, based on 9 principles of sustainable development, our entire organization structure. And what we have done, like we have domain knowledge about in our sector, like. So how we can use this knowledge to, by developing these software and process controls and integrations. And I'll just name a tool called Equasuite, which is majorly meant for water and wastewater technology. And how we have used this domain knowledge by, putting data science and machine learning into this. So today we are sitting in, having these SCADAs and PLC systems on our entire systems like water assets. We found it's like not an industry, but actually the entire city is actually functioning on this water asset, which is running like a big factory. I'll tell you, in Mumbai itself, you need an investment of 25,000 crore rupees to manage the wastewater. Today the water is coming from 130 kilometers away from Mumbai, but it is coming by gravity, but that also involves huge pipelines, pumping stations and treatment plants. Similar is the situation in Delhi. Bangalore is having 3 stages of pumping. The water per kiloliter is costing 170 rupees, which is the most expensive water in Bangalore city. So how to create such economics and efficiency into this system? That's where this tool can help. So with the knowledge of SCADA and PLC is there, the data is generated on daily basis. This tool actually takes care of the historical data, and then in the 3 months of time, if your valves, pumps and system are fully automated, it can take control of your complete systems. And we have implemented in actually entire Netherlands, 40% of UK, complete Singapore assets, and 2 projects now commissioned in India where 200 villages of water supply is completely automated by using these tools. And those villages are actually in very remote places like in Rajasthan, where it's very difficult to send a skilled labor actually. So this tool is very helpful and it is operating there with a contractor. And it can manage the demand supply in each village and where the supply has to be increased into which area. If it is a drought period, how the dams water level is falling, how we have to manage and control the assets. So everything can be controlled through this tool. Sorry if I get to go there. So it took us almost more than 20 years to develop this tool. We did huge investment actually bringing this automation to water assets because traditional engineering and practices are getting very competitive in the market. And when we understood this, our company started investing into machine learning and AI. So we invested in our people to develop this because our company was carrying this domain knowledge. So today I am proud to say that we hold actually 20 patents into this sectors. And in a span of 3-4 years, more than hundreds of projects are executed all over the world, which has created huge efficiencies into energy saving. When these tools are implemented, 30% of electricity cost can be saved, 40% of manpower can be reduced, total use of chemicals into those plants has reduced by 20% because it optimizes your complete treatment system rather than manually intervention into those things. We have seen water treatment plants, they just send one labor or operator to put some alum bricks in the coagulation tanks. This is not the case here. They just put it by the idea, okay, this much of water, put so many bricks into the tank, just operate it. But we don't know whether we are putting it in excess or it is less, we don't know. So this tool can help into studying those parameters. So that's how it works actually. It takes care of your externalities, weather, lab results, whether how much pollutants are coming, what level of pollutants are to be treated. All this data can be analyzed. It can take care of your time and date of any year, any special event, either from tomorrow or next year what is going to happen, or after 10 years what is going to happen to your assets. In fact, it can take control of your assets, that by when you need to organize your pumps, motor and valve after this shelf life is over, or if something is not functioning, it can alarm you. And that's where efficiencies can be created into the system. So this is how a virtual operator can add benefit, whether it is drought conditions to your water treatment plant, to your industrial sectors, to your even these flooding areas. Like we have created certain radars which can tell which area is actually, like for example, we have many CBDs in the city. What of rainfall is there going to happen in the next 3 hours, and how it's going to impact the transport system and your people. So it can give pre-warning that this much amount of rainfall will be there, this much of traffic can be impacted. So we have such tools who can tell that okay, now this area has to be vacated in these many hours because there is going to be traffic jam after 3-4 hours in these areas. So these kind of systems are already in place which we have done. So these are various tools like OPIR is for drinking water supply, burst is for your leakage reduction. Our leakage is actually major problem in our cities. We have actually 40 to 50% of losses in our cities. So this can help identifying the leakage as early as possible so that you can repair it and reduce those water losses. Sewer is for your sewage systems, flow is for your wastewater treatment plant, pure is for your wastewater treatment, and mine is for sludge processing. So today, when we are talking about greenhouse gas emissions, in Ahmedabad city, we are doing complete wastewater treatment plant. It will be 7 plants we are designing based on our own domain knowledge, and then we are also focusing on putting automation on those plants. And what we have been given by World Bank a task that how much greenhouse gas emission can be reduced if we do these investments and if we do automate these plants in the next 30 years. So every year we have calculated around 7 lakh tons of greenhouse gas emissions can be reduced if such tools and systems are efficiently managed. In city like Mumbai, it can be 3 times of that.
Yeah, good evening, ladies and gentlemen.
Good evening, sir.
And thank you for inviting me. I'm absolutely honored to be part of this elite panel here. And I know we are running pretty late, so I'll try to complete my talk in the shortest possible time. A lot has already been spoken about it. 2 years back, in 2000, just bore the COVID started, in one of the parallel conferences of World Economic Forum, I was invited to deliver a talk in Davos on the sustainability. In fact, I was representing FICCI in that conference. During my talk, some people, because I was only Indian in that conference, otherwise most of the people were from Europe and United States. They said, are you taking enough efforts to reduce the CO2 emission in your country? Then I said, no, we are, if you look at the per capita, and I think said about 116th or maybe 150th in the rank of per capita CO2 emission. But they said, no, but you are the 3rd largest CO2 emitter in the world. And the glaciers don't understand whether it is per capita or whether it is, they only understand the absolute CO2. Then I said, yes, we talked about some of the efforts of renewable energy and other things we are doing. But at the same time, I asked the question to the audience, I said, when you grew from a developing country to a developed country, did anybody ask you a question, how much CO2 you are emitting? And that was a very smooth development, and now it is our time when we want to develop or we want to improve the quality of life in our country. You are all asking us a question, what you are doing it. I said, I'm traveling in your trains. Every last 3 days I was in Davos, I'm traveling in your trains in peak hours also, and I have never seen a single train or any single time or any time in a day, a single train occupied more than 50-60%. As we come and see the train in India and see how much per capita emission we are doing it. So I asked the question, why can't you cut down your train numbers and let the trains run full? But you do not want to lose any of your comfort, but you want all the developing countries to drive their emission to be reduced. Recently they said the 7 countries, they said that they are not going to fund any fossil fuel related development in the countries outside their area. But at the same time, see the hypocrisy. At the same time, they are asking, US and Europe are asking Arabian countries to increase the coal output, to increase the crude output. Spain and Italy are huge investing into the African gas. Germany has reopened their coal plant after this natural gas tragedy happened. So whenever any economy is impacted, that time they look at you, they don't want to lose their comfort, they don't want to lose any of their emission reductions plan. And that is why I am saying I am trying to balance of economy and ecology in our country. So these are our, we call it a VUCA world, is a volatile, uncertain, complex and ambiguous world. And these are the mega trends of VUCA world. Many of us have spoken about it. We need to do digitization, we look for a circular economy, not only for plastic but also for fuel. We're looking at decarbonization, we're looking for a clean technology scenario, because when the petrochemical consumption, which is 1/3 of the global average in India today, And the quality of life has to be improved, the petrochemical consumption has to go up. And if the consumption has to go up, automatically emissions have to go up. And if the emissions have to go up, then there are the clean technology scenario which nobody knows about what is it. But they said by 2050, we will cut down the emissions, we will reduce the water consumption by 30%. But nowhere in the form of technology, nowhere is very close to that. So we are working on all of these areas. And I think we spoke about low-hanging fruits in that area. The first low-hanging fruit I see is the digitization, and I'll talk a little more about it in the subsequent slide. And we had a $5 trillion dream by 2024. Because of the COVID, something got impacted, and now the IMF projection is $4.5 trillion by 2026. But this assumes large amount of growth happening in manufacturing. In any of these assumptions of a growth, it is not assuming that CO2 emission will be cut down to stop the development. The development will happen as it is, and the emission will continue to increase. This is as per the predictions of that, and we want that. We want our GDP to go up, and at the same time GDP per capita to go up, and for which those challenges of economy and ecology will have to be taken, and the preferences will have to be chosen. Look at sector-wise the GDP contribution, and here if you see there is the service sector of course is growing, but the industry sector, which has remained more or less constant at 25 to 26% of the total contribution. And if you look at the agriculture sector, which is contributing 18 to 20% of the GDP, is employing more than 40% of the manpower in the country, and which is not sustainable. If you look at all the countries which are moved from developing to develop, the migration from the agriculture has happened into the industry, and that is precisely required in India. We need at least 15 to 20% of the agriculture manpower which has to go to the industry. And for that manpower to go to the industry, industries have to develop. The manufacturing has to build in India. Now many people say, how can you compete with the large plants coming in China, Korea and in many other places? How India is going to do that? But I worked in Reliance for 34 years before joining this US company which is in the business of benchmarking. Reliance has demonstrated, even when large number of competition which was already existing in the world, they said that you can import the crude, you can process it, you can export the product, and still you can make the maximum PRA. So that all is possible to be done in India to grow the manufacturing sector. Today if you look at in agriculture, there are 4 brothers sharing a 5 acres of land. And they are all surviving on the earning of that land. Do they need? There is only one brother can manage, other can go to industry. And that is the way per capita income and the GDP will increase. So manufacturing has to grow in India. It cannot stop its development because there is a threat to the environment or threat to the climate. We have a much bigger threat. There are worldwide, this is 3.5 billion people do not have access to reliable electricity. In India, how many? 25-30% of the people do not have access to electricity. They don't have a roof on their head, they don't have access to the health, they don't have a food on their table. So what is important for me? Important me is to develop the living standard of my country, and that becomes the first priority while doing all these initiatives. We want to show to the world, yes, we are making biofuel, solar, fuel cell, hydrogen, all that stuff, we continue to do that, but not at the cost of stopping any of the development. That's more important. And if you look at what are the key enablers for that, the first and the foremost key enabler for any development is a stable society. What do you mean by stable society? Roof on every head, food on every table, access to health, access to education, access to electricity. So that is, unless that society is stable, no country can develop. And to make that society stable, there are many enablers which have to happen. We've got to improve the productive section, infrastructure and supply chain. And we're talking about the low-hanging fruit. I was just calculating, there are 6 lakh vehicles enter into the Mumbai every day. And if you look at the crawling on the toll nakas and the fuel efficiency which is reducing, and I just made a rough calculation, 1 liter of diesel emits around 2.7 kg of CO2. And if you do the simple calculation, how much fuel average you are losing in that 1 or 2 kilometer queues on the toll naka, just in Mumbai, there are 200,000 tons of CO2 which is emitted because of the crawling of the toll naka. Can we not have a better solution for that? If you go, many of you, everyone has been traveling the abroad country, there are 100 meter, your sensor detects your FASTag and then you pass on. Here you have to stop the car, then the guy comes around and it will detect and that opens it. So they are the simple solutions which are important for us rather than looking for many other advanced solutions. And I also openly challenge the people saying that today if you talk about all renewable development, who is earning and who is spending? All the Western countries, they are earning. You are collaborating, you are trying to invest into their companies, you are trying to make the partnership. Is there any Indian company which is developing a technology and earning the revenue out of it? No. And that is, if you want to do that, why not we enhance our research rather than spending money outside into that area? We can take time. There is no emergency for us because we have many other problems to solve before this climate or global warming. So I will not spend more time. There are all other enablers. And if you look at this big picture of the IP monetization, and where is the India stand? So where that red line which is earning the license fee is almost invisible. But if you look at the China was also not earning much on the exporting the technology, but the green line is much longer. Why it is longer? Because they have adopted the technologies wherever they are available and grown their manufacturing in a big way. So it may take pretty long time for us to get into this area where you talk about the US, Japan and Germany and those people. It's a pretty long game. But what can be quicker happen like in China where you keep on in licensing, it doesn't matter, but then grow your manufacturing sector. So the world is evolving the way we power it on in, and this is what we are talking about, transition from fossil fuel to renewable, and there are many areas where we talked about it. Today we are very proud of solar energy which is happening, but the moment you want to store the solar energy, a 4 crore rupees capex for 1 megawatt becomes 16 crore rupees capex. And today the study says that all the batteries which are available in the world today, if it can store only the power which will last only for 11 minutes. And if you want to have that many batteries are to be produced and store the energy, it's just a long way to go. We can't wait for our development, can't certainly wait for that. Yes, we are doing everything into that area. I myself was heading the planning and strategy part of the Reliance R&D. We are working in each of these areas. We are working on fuel cell, we are working on biofuel, and all those areas. With due respect to Mr. Nandakumar said about the 2G and other biofuel. But where is the economics today? There is a minimum selling price, 63 rupees per liter of the ethanol government is paying. How many private players are entering into 2G ethanol? Not many, because they are all depending upon the subsidy, they are all depending upon paying to the farmers, which is again going to be the agitation by the farmers. We want more money for our waste, so nobody wants to get into that area. And the technologies have not matured to the level where it can compete to the fossil fuel. When it happens to that level, many private players will enter into that area. Sugarcane, yes, that makes sense. It is still economical and compete the fossil fuel. There are 500 licenses that have been issued for the 1G ethanol. And maybe in another 2-3 years, we'll reach to around 18-20% of the ethanol blending into that area. So where there is economy, yes, it is there. But when there is no economy, the amount of money being spent in that area is going to be a huge challenge for the development of our country. And this is, I think it's spoken about it. It's still coal remains the most important area of our energy sector, which is at the lowest cost. And I'm very happy in that COP26 which happened in London. Very clearly know that last minute there was a change. They say phase out coal. And India intervened to say not phase out, it's a phase down coal. Phase out means you say by this time no coal you are going to use. Phase down means it may take another 100 years for you to phase down it. And that was a pretty good stand which was taken by India, and they also talked about 2070, which nobody has seen today. So that's I really appreciate government not budging to the pressure which is coming from the Western countries on pushing something. Because when they are pushing to you, what will happen? They are spending huge money on the technology which they are selling. I worked in the algae development plant. Reliance has spent a huge money, and lot of money was spent into the startups in the abroad to acquiring those companies. We haven't got much about it. But then we say yes, algae has a big future, and it is still going. I commissioned the plant which was making 40 liters of crude oil starting from the seawater. But where is the economics in it? It was coming at more than $200-300 a barrel. And to get into that 60-70 barrels per year, it requires a very long time to happen. And this is, I'm not saying this is the IEC, the source of this report is IEA, International Energy Association, and which also talk about this, something to happen with the hydrogen, where realization of the hydrogen economy, they are talking about 2040 today. So it is good that we are into that area, but I will recommend that we should be in the area where we should be able to license or sell our technology, rather than thinking that we will convert everything to hydrogen. It is going to take about 2040, it says here only, and we talk about the cost of $5, even more than $5 today. The grey hydrogen costs less than $1 today, which is to compete with that grey hydrogen. This hydrogen is coming from $5 to $1, and more importantly, scale. And there is a problem in every area: storage of hydrogen, transportation of hydrogen, dispensing of hydrogen, safety of hydrogen. All the areas the things have to develop. So this 2040 is also a very, very optimistic target for that. So coming to what is all happening in this automation area. So this is what it says. You can economic benefits are happening from industry 4.0, 5.0. We talk about it. If you look at the causes of abnormal situations, the upset, human readiness factor 35 to 45%. If we attack this area and all the technologies which are being displayed in this Auto Expo, if they have been adopted by the industry, a lot of these things we can change. And as somebody talked about improving the efficiency, so that is the easiest and the fastest way for us to minimize the CO2 emission. It will not only reduce the CO2 emission, it will improve the productivity, it will improve the profitability of the largest number of companies. So that should become the largest focus area, and I really appreciate whatever small part I could see of this auto exhibition. There are huge solutions into that area. In fact, these people should not be struggling to sell their technology. There should be industry coming to them to give us something we can improve into this area. And automation is not an expenditure, it's an investment that needs to be done. That's right. So, and that is what my Reliance company where I work, I think Mehta sahab know, Mr. Ambani used to say that if you consider any digital thing is expensive, you do not know how to do it. No digital solution can ever be expensive if you know how to do it. That is what very clearly was said. And this is again the World Economic Forum before on the digital transformation. And I will not go to all these things, these are all solutions which are already been spoken and discussed. But only thing what is written here is environmental reduction in CO2 of 110,300 billion tons to 1.3 billion tons, and water saving of $800 avoiding oil spill of this much of barrel. So this is the potential of the digital solutions happening into the oil and gas industry. And all these things are existing. And if you look at each of the solutions which are there, that all has been displayed somewhere into this exhibition. And today the innovation is not like telephone took 75 years to reach 50 million people. It is, it happens in minutes and days, the things which are happening. The world is moving at that fast track into the innovation area. And all this automation or digitization, which are the proven areas, really help this company, industry, this country to grow. And again, taking away from the flock, it's like a ship of the flock of the herd. There is only one gate, they all be passed from there, even if there is no water in other areas. So we need to work into that. And this is not a big fan of Modi, but I certainly like it, the way digitization has happened in this country. Even today, earlier, 2 years back, we were forcing take credit card or take digital payment. Today, vendor asks us, "Sir, Google Pay दे दो, ऐसा मत करो." Even 10 रुपया होगा तो बोलते हैं Google Pay दे दो. And that's a magic of whatever has happened in last 3-4 years of digitization. So thank you very much, and once again, thank you for giving me an opportunity.
Thank you so much, sir. I'd like to now call upon Dr. V.P. Raman to join us on stage. So.
Yes.
Good evening, everybody. I think everybody is running low on energy. Good evening, everybody.
Good evening.
Very nice. I don't want to stand between this place and that place. We try to minimize our effort. See, we have heard all the speakers, their viewpoint. We have heard experts like Dr. B.R. Mehta, Dr. Nandakumar, then Mr. Marathe, then we had Anil Kumar and Mr. Srivastava. they are given a clean picture about what is the present status regarding the net zero and how we can achieve and what is the time frame of achievement. We have heard from dear Mehta regarding what are the impact of net zero, what are the criteria which drives towards the net zero. Then we heard Mr. Srivastava giving details on what NTPC has done on the power front and what can be done on the power front to reduce the carbon footprint. Then we had Dr. K. Nandakumar who gave us a clean picture about the contributing factors towards the carbon footprint and what are the remedial solution to that. Like say for example hydrogen, ammonia, ethyl alcohol, etc. Then we had Mr. Anil Kumar who talked about water and wastewater system. And water and wastewater system, what are their takeaways, what are their solutions, what their system acoustic can do to improve the efficiency on water and wastewater. Then finally we had Mr. Marathe, Vinayak Marathe, who gave us details on the economic front as to what is the present scenario, when is it possible and how is it possible, and the time frames. All the speakers have given their criteria of time frame and how do we achieve. Now looking at all these things, I don't want to go too much into the carbon footprint or how to achieve net zero, and simple bulleted points. I would say that there are 10 points which are important for carbon footprint reduction. One is a renewable, which we all know, solar, wind, etc. Number 2, batteries and battery storage. Number 3 is battery recycling, heat recycling, recovery plant, etc. Number 4 is building technologies like geothermal heating, electrical equipment, etc. Then industrial process innovation. Many of us are from the process industry. Like say for example electrification of the heat process, which Mr. Dr. Nandakumar has talked. Then green steel, green cement, etc. Hydrogen. We all heard all the speakers talking, emphasizing on hydrogen fuel cells, etc. Then sustainable fuels. We heard about biofuels, e-fuels, biodiesel. Then nature-based solution, like most important thing is today nature-based solution, monitoring of forest, mangroves. Then finally carbon removal, capture and storage. Having heard all these things from all these eminent speakers, we have got a picture where do we stand on that. Now coming to it, as instrumentation and automation fraternity, we can and must do from what we can do from our side. From our side, what we have to do is, we talked about increasing the productivity, efficiency. This is one of the things which is very critical and we can contribute towards increasing the productivity and efficiency of any plant. Number 2, we talked about smart building systems, robotics and digital twins. So we have been hearing about digital twins for quite some time, but unfortunately we do not have a clear picture in what way the digital twin will help us. So now looking at it, we know that digital twin can help in getting an ideal condition to the actual condition. So the difference between the two is what is going to be measured and how we can reach from the actual position to the ideal position. Then we have got technology which are going to the positive side as well as to the negative side. So now I don't want to take any question and answer session on these topics, whatever we have discussed, because all the speakers are available here and we can directly approach the speakers, ask the question, talk to them and get a detailed idea or their perspective of how to achieve net zero. And the last thing which I liked about Dr. Mehta's thing is net zero means everything zero. Coming down to it, no accidents, no fatalities. Bottom line is no accidents, no fatalities, And if you look at it, when there is no accident and no fatalities, ultimately we talk about cars which are autonomous or which are running on green fuels. So with this, I don't want to stand between this table and that table. So I would like to end my saying from here. Thank you very much.
Very good.
Thank you very much. Now, please.